All right, good morning, everyone, and good afternoon in Vietnam. My name is Etienne Espagne. I'm a senior economist at the French Agency for Development. And I'm very happy to open this third session of our webinar series based on this recently released COP26 special reports on climate change in Vietnam, impacts and adaptation. For those of you who were there in the first two sessions early January, you know that all this month we are trying to have a sequence around the question of the Mekong emergency. So after two sessions where we dealt with the more biophysical side of the environmental questions around the Mekong Delta, today we're entering into the more socio-economic side of things. And for this, we will have today Professor Alexis Drogoul from the IRD and Dr. Quang Truong from Tho Universiy. And they will be talking about modeling dynamic adaptation strategies in the Mekong Delta. So Alexis and Quang, you will have 30 minutes of presentation. Then we will have two discussants starting the discussion. So Professor John Ward from the Mekong Region Futures Institute and Professor Van Pham Dan Chi, who is the director of the Research Institute for Climate Change at Tho Universiy. So both of you will have more or less 30 minutes as well for discussions and Q&A with the authors. And then we will open the floor to the public and for 30 more minutes. So please be aware also that this webinar is recorded and will be put on a specific YouTube channel of IFD. So just for you to be aware. So without further introduction, I give the floor to Alexis or Quang. I don't know who is starting the presentation.
I will be starting. So thank you very much, Etienne. So good afternoon to everyone in Vietnam and good morning for those in France. And I know that one of our discussants is Australia, so good evening to him. So I will immediately share my screen for the first slide of the presentation. Here it is, so you should see it now. So Quang and I are going to talk about modeling dynamic adaptation strategies in the Mekong Delta. So it corresponds more or less to chapter 10 of the report, and you will see throughout the presentation that we will actually use other chapters of the report to make links between the different topics that have been introduced in this report. So basically, I'm going to talk, I hope briefly, about the general context of these research and also more methodological aspects of our work. And why we chose to use a specific kind of modeling technique. And Quang will introduce actually the concrete work which has served as a basis for this chapter about the modeling of the different adaptation and co-adaptation strategies that occur in the Mekong Delta in terms of land use changes. So I will begin by the context. So for those of you who have been there already in the two previous seminars, or for those who have read all the reports, okay, nothing new will be presented here, but it's important to recall a number of facts, and I will browse through them quite briefly, actually. So the Vietnamese Mekong Delta is clearly something extremely crucial for Vietnam. It's a symbol. Okay, it has been left completely devastated by war in 1975, and now contributes to something like 27% of the national GDP, with a number of figures in terms of rice export and fish export, etc., etc. it has been also secured as a kind of, well, not only a symbol, but actually a basis for the food security of the country and it now produces in 2021 a little bit more than 50% of the nation rice, 80% of the nation fruits, and 60% of the nation fish. So that's really huge in terms of importance within the country. And actually, it is something you can find much more developed in chapter 7 of the report. These pressure, well, actually, these developments and these really intensive developments since the Doi Moi in the late 80s have made the Vietnamese Mekong Delta become the subject of something that has been already described very well in the two previous seminars. Actually, a very strong anthropic stress, okay, pressure. So by demography and urbanization, sand extractions, dams building upstream, destruction of mangrove forests, water and soil pollution, and intensive agriculture. So this has been already presented, and the consequences of these anthropic stresses are already visible for anyone living or traveling through the Vietnamese Mekong Delta. It's already visible, and it has been increasing in terms of visibility in the last 5 years, since the big drought of 2016 and the episode of extreme salinization of the rivers. We have seen more and more of these impacts become visible and measurable in the Mekong Delta. So you have on one hand subsidence, and it has been very clearly shown last week, between 2 to actually 6 centimeters a year, depending on the place, which increases the risk of permanent inundation of some parts of the delta. Spontaneous flooding by brackish water in the main cities, okay? Coastal erosion due to the decrease of sediment transport, mangrove deforestation, drought episodes, with things like groundwater estimated at its lowest level since a long time ago, almost 100 years ago. The increase of soil and, well, water and soil salinity up to 100 kilometers upstream, etc., etc. So a number of things which actually we can already measure, okay? We can already face in the delta. And if you combine this with the projected climatic stresses, which are abundantly described in chapter 1 and chapter 9 of the report, okay? If you combine all of this with what is projected in terms of downscaled scenarios of rainfall, temperature, and then of course the impacts of these changes, we see that, well, they promise to be extremely severe for the moment if nothing changes. Okay, so not only based, of course, on local emissions of GHG, but of greenhouse gases, but also because of the pressure I just mentioned before. Okay. And we see that actually a number of pillars, a number of elements of the delta are or will have a risk of falling, like, for example, biodiversity. We know that the ecosystems of the Mekong Basin are really in danger, and actually in danger of changing. So we don't know exactly how they will change, but they will change. We can see also a number of other impacts in terms of extreme weather episodes, possibility of storms, droughts, big cycles, big climatic cycles, etc. Well, change in the cycles. So the problem of the existing anthropic pressures and what is projected right now is that each of these different stresses identified here act as a catalyst for the others. Okay, so it's increasing vulnerability to flooding, permanent inundation, saltwater intrusion, etc., etc. So we have a kind of feedback effects of each of these stresses on each of the others, which at some point creates well, conditions where, without dedicated measures, we know and we can now measure that the impacts of all these existing stresses and projected stresses will harm the population in a way or another. And it is something that is documented in chapter 4, 3, and 6 of the report in different sectors, of course. But if we focus on the Mekong Delta, we have, well, of course, submersion of the major urban centers without measures, again, risks of economic and political instabilities, climatic migrations, up to 10 million people estimated, disruptions of communities, transportation lines, etc., etc. And regarding the health and security of people, we have an increased exposure to hazards, diseases of the majority of the population of the Delta. And in terms of economy, a decrease, severe decrease actually, in agricultural and fish production, which actually might threaten food security nationwide. So what is Vietnam doing, and what are the different authorities and actually sectors of the population doing when they face this kind of threats? Now that a number can be easily, well, not easily, but at least more easily than 20 years ago, shown and measured and demonstrated. You have, like in any other part of the world, two main kinds of measures. Some are under well, the broad definition of mitigation measures, okay, which mitigation being measures that actually are supposed to address the causes of what's happening right now. So of course we have mitigations against climate change, so by reducing emissions mainly, but it's a long-term goal, okay, and it's a goal which is not completely in line with the 30 years horizon of the major impacts I've just described. Okay, so we have also mitigation measures in terms of trying to regulate groundwater uses, sand extractions. Okay? But again, it's a kind of long-term benefits which can be expected, not short-term ones. And of course, also these mitigation measures should also concern other aspects, like reducing the impact of dams upstream. Okay, but here we jump into something a little bit different, which is the water diplomacy around the Mekong region, which is actually the subject of chapter 8 of the report. Or economic problems, okay, like for example, if you want to reduce or regulate sand extraction, if you want to reduce the intensity of the agriculture, intensiveness, sorry, of the agriculture, then at some point you enter other dimensions of mitigations, which are more political and then technical. And then you have also a set of measures which we can probably sort under the terms of adaptation measures, which are composed of a number of short to mid-term measures aimed at reducing the vulnerability to environmental and climate changes. And actually, adaptation measures are here to address the consequences of, well, future consequences of the climate change, but also consequences of the actual anthropic stresses. So it can concern infrastructures, new developments, reforestation, land use changes, promotion of new agricultural practices, migration, training, etc., etc. Okay, so that's what we have been interested in with Quang in this chapter and other authors, of course. And this is what I'm going to introduce here. Adaptation. So I've described a set of measures, and actually these measures are at very different levels. And we can find adaptation measures that can be decided by individuals or decided by collectivities or governments or regions, world regions. Okay, so when we talk about adaptation, we must be careful about what we're talking exactly about. There are different kinds of adaptation, and actually in the literature, you can find 6 main categories. So anticipatory adaptation, when you decide things before impacts of changes can be observed. Okay, so this is, for example, what happens right now in different regions regarding climate change. Autonomous adaptation, which is an adaptation which is neither planned or decided by anyone, but just occurs because of the changes in the ecosystems, because of the changes maybe in rainfall, salinity, or whatever. So it changes things, and we can observe these as a natural or, in that case, autonomous adaptation. Then you have two categories which are completely separate. On one hand, planned adaptation, so the result of a deliberate policy decision based on the awareness that conditions are about to change. So usually it goes together with anticipatory response. And reactive adaptations, which takes place after the impact of changes have been observed. And it usually goes with autonomous adaptation, but not only, not always. And then after that, two other categories. Private adaptation, which is initiated and implemented by individuals, households, private companies, and public adaptation, which is in that case initiated and implemented by institutions, major institutions. In the case of the Mekong Delta, it can be, it can be from the villages to the government, okay, and of course, district, provinces, etc. So have their say in what kind of public adaptation should be implemented or planned. Public adaptation is usually, but not always, directed at collective needs, needs of the collectivity. So if we combine these different categories, we have a number of qualities that we can and a number of descriptions we can have of what is happening right now and what is planned in the Mekong Delta. For example, we have a very interesting paper by Alex Drogoul in 2015, I think, that after a survey that shows that private anticipatory adaptation is almost non-existent in the Vietnamese Mekong Delta. Okay, it means that actually people adapt, and but maybe they don't adapt to climate change. Okay? They adapt to different things. They adapt to whatever they are perceiving as changes in their environment. Okay, so it's a private adaptation, but actually which can't be described as anticipatory with respect to climate change. It's more either autonomous or reactive. And research we have done with Wang and another researcher and me also observe in terms of surveys a predominance of private reactive or autonomous adaptation among farmers. Okay, so again, not to climate change because it remains a very abstract notion, but to environmental changes already occurring, like salinization of water. Of course, Vietnamese institutions and among them the governments are pushing for anticipatory public planned adaptation. And you can find some of these categories also in chapter 12 of the report, and with very interesting surveys also about how from the field, in the field, okay, among farmers, how climate change adaptation is perceived or not. So when we regard, so sorry, I will come back to this one. So actually, what has been pushed forward is anticipatory public planned adaptation. Okay. And right now it is the main, how can I say, the main way of describing the different policies that the Vietnamese government is either implementing or planning. The thing is, to build these policies, we see that very few tools actually exist to support this kind of long-term adaptation planning. So I will not go into the details, but one of the reasons is that actually it makes very little sense to plan adaptation measures or global adaptation measures without taking into account the dynamics of reactive or autonomous adaptation mechanisms. Okay. So this is what is called This is what is called co-adaptation. Usually, is that if you want to implement something as big as an adaptation policy for the whole scale of the Mekong Delta, then at some point you have to take into account what occurs at the local levels and the diversity of what occurs at the local levels. There are many reasons for that. Some of them historical. Okay, we have seen in the last 5 to 6 years that most of the main changes for example, the shift from rice production to aquaculture in some regions, has not been planned at all. Okay, it's not a result of planning. It has been a result of autonomous reactive adaptation by farmers. And not taking this kind of dynamics into account might severely harm actually any adaptation plan or global adaptation plan. To go on with this idea, actually, the fact is that human groups, human collectivities, and individuals cannot be considered as passive targets, okay, in adaptation planning, because people will be the one who will ultimately implement or not adaptation measures. And these people, they are like us, like me, actually. Maybe you don't make any mistakes, but I do. Okay, they make mistakes, they make other choices. Their opinion can change over time, and this opinion can also be shared with others. And they are also capable of invention. And we must, at some point, use this capacity of innovation from the field in adaptation planning. So adaptation plans decided by the upper levels are only one of the incentives that make them change over time. There are many other opportunities, like market opportunities, okay, that exist, and also a lot of other constraints, like biophysical constraints where they live. Okay, and of course, people maybe it's a surprise for many of you, but it's not for me. I'm not always rational in the choices and do not always reason on the long term. So you can't expect people to reason when they have to feed a family to reason for the next 30 years. Okay, most of them, maybe unfortunately, but will reason for the next season. And they do not always agree with one another and follow the most reasonable leaders. Okay, that's something which has been shown in many surveys, like the paper I'm citing here, very interesting paper on this. So co-adaptation, if we want to build tools that support this kind of adaptation planning, and mostly there will be models, or at least tools or dashboards or whatever you want, but based on models, okay, they must take into account at some point social and behavioral factors that affect how people adapt to climate and environmental changes. So I will browse quickly through this, but actually, my point here is really to rehabilitate, and it has been done already in the report, but I think it's important to rehabilitate social science perspectives on the adaptation to climate change. So it can't only be technical. It can't only be economic, okay, at a global level. At some point, we need also to work on how people feel about changes, how they react to it. And it is really essential in these different models that at some point, I hope, policy deciders, policy makers will use in their reasoning or decision-making processes. It is essential to use these, to include disciplines such as anthropology, communication, demography, economics, political science, psychology, and sociology, to be sure to account for actually how people's knowledge, experience, memory of past events, perceptions, attitudes can shape their response to weather or climate risks. And ultimately, how it can influence the way they will implement the plans, okay? Implement the adaptation measures. We need also at some point to move away from the classical, I put here classical uses of models. Actually, we can't only expect to be able to rely on models that will predict, forecast what is going to happen. Okay. All the models we are manipulating are completely wrong, and they will probably prove completely wrong in 30 years. But we need these models to be able to make thought experiments, to be able to support maybe the participation of stakeholders, to be able to explore different scenarios. And here I advocate the use of models, which is more actually experimental than for forecasting or backcasting, so for planning things. Okay. using different scenarios enables people also to consider different alternative ways of building adaptation strategies. And these can also provide some ways to interact with civil society, interact with stakeholders, interact with different groups and maybe NGOs, from NGOs to trade unions, which are usually not really involved in this kind of policy making. So lots of support tools are available, and there are no really integrated solutions which have been proposed so far. And actually what is really needed, it's models that can couple biophysical information and projections, forecasting, together with economic, social models with explicit representation of behavior and adaptation choices of people. Okay. Well, when I say people, it's individuals, of course, but also institutions, which have their own knowledge and reasoning ways. So there is one computer-based methodological approach to modeling, which I know quite well, and that's why I'm talking about it, because I'm not an expert in many other things, which is called agent-based modeling. And this is precisely the one we used in this chapter, and the one which will be presented by Quang. So very briefly, what is agent-based modeling? It's a kind of systemic, individual-centered representation of the world or of a system that is of interest to someone with a question that allows to reconstruct and explore what I call here synthetic worlds, okay, or virtual worlds, if you want. So basically, it goes, well, not in 3 steps, because it's usually a little bit more complex than this, but the first question, the first phase is about trying to identify the main actors and drivers of a system. Okay, so before trying to understand how the system works, we try to describe what it is composed of. And so what are the main actors on which, of course, we can have some knowledge or data. And then we represent these actors and drivers by things, well, computer things, okay, computer programs, which are called agents, and which are capable of communicating, capable of interacting. And if you use some AI techniques, they are also, they might be capable of autonomy. Okay? And you gather these different agents, sometimes these millions of agents in synthetic environments, which they are fed with realistic data. It can be GIS data, it can be economic data, it can be, of course, behavioral data. And then we execute these things on computers. And when we execute this kind of synthetic worlds, it's called simulations. So we have here something that allows us actually to build virtual experiments on synthetic worlds. And we have, so of course, these synthetic worlds are a little bit simpler than the ones in reality, but we can still keep some of the complexity of the world, which can provide some heuristics about what to change or what to define, maybe what to introduce in order to get to some objective or to answer to some question. And so agent-based modeling has many advantages actually when dealing with a complex socio-environmental system, is that we can incorporate a number of different types of data, okay, like quantitative data, spatial data, etc., etc. It's quite modular. We can remove or add entities during simulations. It provides a lot of flexibility, and any formalism can be used to express the dynamics of agents, allowing different models to coexist in the same model. One very interesting thing is that these kinds of models are called generative. Actually, we represent behavior at a micro level and generate outcomes during simulations at one or several macro levels. So we can work on the emergence of features, emergence of properties, emergence of behaviors, okay? And this is something which is absolutely crucial when dealing with uncertain futures. Dealing with conditions that we know partially. So I will skip this one because I'm very late. So the pros and cons of this kind of modeling, and you will see a little of it during Quang's presentation, is that actually pros, they support an experimental approach in domains where it's impossible. Okay, if you're dealing with social modeling, well, social systems modeling, we can't experiment on people, or not easily, at least. The only ones I know that can do it are experimental economy, and it's very limited in terms of hypotheses. So here we can support a kind of experimental approach to define scenarios, to maybe think and imagine new adaptation policies, etc. We can couple models from very different disciplines. Examine the role of the role of heterogeneous actors and their behavior and interactions, support changes in the level of analysis, and something which is very different from other perspectives in, for example, economic modeling, is that we consider changes at the macro level to be outcomes and not inputs of the model. Okay. So we can work on emergent features. The cons and the problems, the drawbacks of these approaches are that they are really data intensive. We need a huge load of data, and sometimes in every possible domain. When we have to deal actually with representing a population, then at some point you need, depending on the question, of course, you are addressing, but you will need results of surveys, you will need maybe qualitative data about how people make decisions, etc., etc. It requires quite important expertises in programming. Okay? These are computer models, and they are actually programs. And it requires expertises that we can't find right now, but it will change, of course, over time, but we can't easily find in different domains. It requires additional computer systems or computer methods, like generation of synthetic populations, exploration algorithms, which are very close to artificial intelligence techniques, etc., etc. There is a large set of input parameters, which makes it difficult sometimes to analyze what is really produced by these models when we change something. And we have an issue of upscaling, because at the level of detail where we can be sometimes, it's difficult to embrace very large populations. So it has to be, and this is how Quang will present it, actually, represented as a, well, a very interesting tool, of course, very complementary to other approaches, which can help in building models of quite complex socio-environmental systems, where we keep some of the complexity of the system in the model, in order to be able to explore the effectiveness of adaptation strategies in various scenarios. Okay, and now I'm very late. I'm sorry for that. We have to move, and we will move to part 2, which will be provided and by Chung-Chi Quang. So Quang, if you're ready, I will stop sharing my screen and
yes, I'm here. Yeah.
Give you the floor. Thank you.
Hello, can you see my screen now?
Yeah, perfect.
Okay. So my name is Chung-Chi Quang. I'm a lecturer at the Tho University, College of Environment and Natural Resources. I would like to introduce with you our model. We have proposed LUCA, a model called LUCA. It's a land use change model for adaptation strategies. So for our model, the objective of our model is to try to understand the land use changes in the Mekong Delta. And we would like also to compute the land use area exposed to risk due to climate change. And based on the model, we would like to test the adaptation strategies in the case of climate change. So the main idea for our model is based on this Venn diagram. Where in terms of during the simulation of land use change, the land use can be impacted by climate change, and we can identify the exposure areas for different land use type. And when we apply the adaptation strategy, we can for land use, we can reduce the exposure area, And the potential exposure rate would be recognized as the vulnerable region. And for the next step, we can try again, apply the adaptation strategy. So that is the mechanism of the model. So I would like to introduce a little bit about our model. Our model is based on the agent-based modeling approach, and we use the Gamma modeling platform to implement the model. In the left-hand side, you can see the block green boxes, and that are the social, economic, and environmental data. It's called the environment in terms of agent-based modeling that Professor Alexis Drogoul talked about. And in the middle, we have the actors. And in our model, we consider 3 kinds of actors. The first one is the farmers. The farmers are the land use decision. So they can have a 2-man action. They can select land use and based on multi-criteria analysis. And the second thing, they can apply the adaptation strategy to reduce risks of climate change. So the second thing, the second actor are the district actor. They can select the adaptation strategy, and they can have the financial support for farmer. And the lobo is in the agent-based model is also a specific actor. The lobo can compute the exposure area, update maps, and they can also it can also calculate the vulnerable area. For the output, we define the indicator for the land use area, the vulnerable areas, and the adaptation scenario, and also the financial requirement in case of apply different adaptation strategies. Here is the main entities of the model. The model is quite complex, but we would like to present the simple things. You can see here the main entity is the farming unit. Farming unit in the model is we represent the farmers, also the land. We call a farming unit, and they can have the budget, a land use type, and for action they can select the land use based on criteria, and also choose the adaptation strategy and compute the revenues every year. The farmer and farmer unit relates with located in the district, and then it also located in the land unit. Land unit is an entity with the different properties of environment, and so there is land soil type, salinity, the climate conditions, climate data. So for a land unit, the property of land unit come from the sub-model, the salinity and the climate. In our model, we don't have a complex salinity and climate model, but we get data and provide data from a data series. The methods, here the methods for individual decision of farmers is based on multi-criteria. So for land farming unit, it have a land use type, and every year farmer have to select a land use for the farming unit. So the land use type here are the candidate for multi-criteria decision select. So for farmer can use a weighted mean function to evaluate the different candidates. We have the 6 candidates, 3 rice crops, 2 rice crops, agriculture, fruit tree, and so on. So this function can evaluate the convertibility index for every candidate. based on the profit for retail profit, ability to convert, and the influence of other farmers. In this case, we count the number, the percentage of farmer, the neighbor farmer, they are doing the same land use time with the candidate. So after evaluate on the candidate, farmer can select the good one to apply to their field. Calculate the exposure area and vulnerable area for land use, we define the different parameters in which we focus on two kinds. The first one is rise. When we apply the parameter, the threshold, the maximum temperature, and the minimum precipitation tolerated for rise to analyze, to recognize the risk for rise area. And also for stream, the same way, but we use the maximum temperature and maximum precipitation would impact stream. And we also define the different adaptation parameters. We have the percentage of right farmer, they can adapt, apply the adaptation strategy, and the percentage of our culture also, they can adapt, apply adaptation strategy. And in the model, we have two specific indicators, exposure area and vulnerable area for rice and our culture. So the method to compute exposure areas is based on the condition and the threshold of crop farming unit and our culture unit. For crop farming unit, we looking for the farming unit located in the right protection for the right dike protected area, but impacted by saline water. And we are looking for the monthly hydrate temperature in the right season. If it exceeds the crop's tolerance threshold, and also the rainfall, also consider. For our culture farming units, we are looking for the condition about the precipitation. If it's above the cut-off threshold, we can mark it as noted it as risk exposure area. So after that, the total area at risk of our culture and crops is determined by the total area at risk for each type. For adaptation strategy, when we define them, when we calculate the exposure area, in the case that farmer do not apply any adaptation, we show the picture, the current picture when in case that farmer don't apply any adaptation strategy. So after that, we define three different experiments. The first one is the individual level adaptation. In this case, only farmer they react with climate change. They can seek the appropriate land use to eliminate risks. And the second one, in this case, specific land use would be selected. Instead of 3 rice, where the farmer can select the 2 rice crops. And for stream, they can invest money to be able to apply new techniques to avoid risk. And for district level strategy, the government, the local government can have farmers to eliminate risks by invest infrastructure, and they can support farmer to remove risk. And the mixed strategy is to combine between the individual strategy and district strategy. So in this case, the district can provide financial support for farmer, and they can keep they can do 2 rice And for intensive stream reduction, the government can support them by bank loans. So after define our model, we would like to try to use our model to analyze the impact of climate change and testing adaptation strategy. So we have to prepare input data and simulation land use change in the normal condition, and we would like to apply or dynamically assess the exposure land use during the land use changes for the future, and also we would like to test different adaptation strategy, and would like to looking for the optimized solution. So the case study located in the Mekong Delta, and so we repair the land use, the input land use map in 2005. The model is calibrated with land use in 2010 and validated with land use in 2015. And for the social economic data, we collect the cost benefit of different land use type for the candidate. And for the environment data, we collect all the soil data, salinity, dive map, and also the climate data. So especially for the climate data, we use the temperature and precipitation to identify the exposure area. In this case, we have a lot of different climate model. From the chapter 1, we got 31 climate model. So in our model, we decided to get the maximum one from the maximum temperature from of 31 climate model and minimum one of climate model. In the same way, for the total precipitation, we also got the maximum and minimum total precipitation, monthly precipitation of 31 climate model from chapter 1. From the data sets for the 2016 until 2015. And for the salinity water intrusion, we get the data from chapter 9 of the report, and we use the salinity water with 8.5 RCP scenario for the Mekong Delta in 2013 and 15. So for our first result, we have analyzed the exposure area in case without any adaptation. And you can see in the left corner, left lower corner, we can see the land use changes. The main change is the farmer convert from rice to other kind of crops, and but the stream area increased. And the two maps show the exposure for area for our aquaculture in blue one, and the exposure for rice in the red one color in the maps. And in the lower right side, we can see the chart of the exposure area for our culture and rice. You can see the area for exposure area for our culture in green, but inversely the exposure area for rice decrease because the rice area would reduce during in the normal condition. The farmer already changes to the other type crops. So with the decreased area, we apply the different scenario, different adaptation strategies, and we got the maps, and we can see in the result show that we have 3 maps in land use map in 2030, and the third one is the combination. The combination of the two strategy. You can see here the cyan color represent the rice stream, And in this case, regime area reduced. But the dark yellow one is represent the true right crop, and the true right crop still remain the same in the first solution, compared with the solution that they don't want to convert from tree right crop, the light yellow, to true right crop. So this one can provide to the seeder many different solutions, and they can select the appropriate one for their decision. So for vulnerability assessment for adaptation strategy, we found that we have applied the model, and we explore different value, different cases. So we explore the other percentage of adapted, the percentage of farmer they apply the adaptation strategy. So in this case, we show only 30%, 60%, and 90% of farmer who have applied adaptation strategy. For three strategy, we can see here for one who applied the first strategy, the vulnerable for rice would decrease quickly. But in the second case, the farmer don't want to convert from tree right crops to right crops. The risk area will still very high, even we apply a lot of invest of infrastructure or something. So regarding for our culture activity, we can see that when we apply the mix strategy, when a number for in this case, for example, 90% of farmer they can apply the adaptation strategy, the risk vulnerable area would decrease quickly, very strongly decrease. So with our model, we can conclude that we have developed a model that can that take into account socio-economic and environmental factor for land use dynamic, and the impact factor for climate change are also taken into account. But we only consider temperature and precipitation and salinity water intrusion. For adaptation dynamic, we provide a way for testing different strategy. And we know that the farmer are the one who decide the adaptation solution, but the government policy can impact individual strategy and can reduce risk. For quantitative measurement and testing adaptation strategy, this kind of model can provide a way for multi-angle vision in a large-scale area where adaptation behavior are complex. So for during the work, we found that under climate change, there are a lot of impact factors should be considered. So, for example, in the underground water attraction could be impacted to land use selection and land subsidence, and also can impact the policy of the government. And the riverbank or river erosion is also a very serious problem. So we would like to take it into account in the next study. And the second thing is the macroeconomic, because the cost and benefit is not for the future. We collect the data in the past, but we would like to predict something in the future. So the macroeconomic model would be important for us. So we would like also to integrate this one into the model. And for the local provinces, they can share the same arrow ecological zone. So they can share the same strategy. And in this case, the provincial level, the provinces in the Mekong Delta can have a kind of cooperation. And we would like to integrate to our model way for testing the cooperation between the local government. And so that our perspective for the model. Thank you very much for your attention.
Thank you very much, Quang, and thank you, Alexis. This week again, we went well over time, but that's fine. As this was very interesting presentations for both of you. I think we should move quickly to the discussions, and maybe we can start with Professor Van Pham Chi from Tho University, then directly move to Professor John Ward from the Mekong Region Futures Institute, and then Quang and Alexis, you may answer both, both comments or discussion points together, right? And for the general audience, you may ask questions or comments on the chat also directly. I will do my best to refer to your points. So, Professor Van Pham Chi.
Thank you very much, Mr. Chairman. Thank you very much for the work done in presentation from Alexis and Quang. You can see that the work done is very much comprehensive and very much useful. We have great lectures from Alexis, and then we have a good demonstration of modeling from Quang. It is a good combination. I have learned a lot from your presentation, and I can see that especially in the slide Alexis mentioned about the private anticipatory is almost non-exist in the Delta, and it was published in about 2015, and up to now, with some of our work, we still can find it. So actually, what we are now trying to do is to develop a visual proposal, and then we try to seek for reasons why it is still there. Is it because of the governance structure, or is it because of the capacity of different stakeholders, including farmers, local government, etc., scientists, for example? And you also mentioned about the anticipatory public and plan adaptation, which is promoted by the government. So we also, from our research group, we would like to find is it right to do, and then if it is right, how we can promote it. So it is just to come back to what I said proposed in his presentation, and the with one presentations, we can see that we can play a lot with different adaptation strategies. Yes, as a numerical modeler, we can do a lot with the strategies, right? Sorry, with the different scenarios. But the question is how useful the scenario is, because you can imagine, right, different scenarios, thousands, millions of scenarios, but then how it works in reality, how to support the development of the Delta. I think it is one of the key questions. And so, you know, in our Tho University at the moment, we pay great attention to the impacts of our scientific study. So we try to include different stakeholders, including government and local farmers, into research to try to visualize scenarios that have meaningful scenarios for the reality. And also about the numerical modeling, you know, like a certain model could be improved continuously over time, given the advance of the IT, right? But then, you know, like we have here, we are listening about the agent-based model, which is to deal with the social behavior factors. But like myself, as many of you know that I am very much about the physical aspect. So I'm going for the hydraulic modeling. And at the moment, there are still quite some challenges to let two types of model to talk together lively. Normally, we have the result from our numerical model, no matter what type it is. But we have a certain result, and then we have that result input into another model and join another model again, right? In reality, it doesn't work like that. So I know ISC in the group is working very hard to develop different ways to try to let the model work to talk together. So I would like to hear from ISC in the group to be updated. You know, how far have you gone on this process already? Yeah, so yeah, thank you very much for the presentation today, and I learned a lot. So yeah, back to you.
Thank you very much for your comments and questions. I suggest that we move directly to John Ward, and then Alexis and Quang, you might discuss both comments together. John Ward, are you with us?
Sure. Thanks, Etienne. Can you hear me okay?
Yes, very good. Very well.
Okay. Hello to everyone, to Tri and Chung and Alexi, and friends in Vietnam and everywhere. Glad to see that everybody is safe and well. Look, firstly, I really think that the AFD and ERD and this whole report that you put together, you really need to be commended for it. It's a really important document for the Mekong Delta. For chapter 10, Alexi and Chung, you know, what you've really done is provided an empirical basis, you know, to highlight the acute and chronic stressors affecting the ecosystems, agriculture, and the livelihoods of dependent communities. That's really the essence of what's been achieved here. So I commend you for that. Particularly this idea of incorporating and making visible the idea of interdependence, the idea of emergence under conditions of uncertainty, and this behavioural diversity, and actually managing to capture that into a modelling system is a really important advance in managing and helping decision makers and communities actually manage these stressors that are affecting the Delta. This idea that Alexi introduced of this adaptation typology is a really, really useful piece of work. So we look at this idea of reactive, anticipatory, private, public, and so forth. This is a really important point because, of course, Alexi mentioned this idea of rationality, and there's been work we did quite some time ago on behavioural economics, where we asked researchers, we asked policymakers, we asked farmers and so forth, a very simple experimental economic question. Essentially what happened is 3 groups came out of that. There was what we called Homo economicus. They acted as rational economic agents. Then we had Homo reciprocans. These were people that acted as other regarding agents with altruism. These were very small percentages of thousands of people that we've asked this question. The majority of people, including policymakers, are what we called Homo psychologicus. There is no rational theory that explains why they make these decisions. It's a really important outcome. Somehow we have to incorporate this variability of behaviour, which may not to us be rational, but to them it is. So this sort of modelling framework that Alexi and Chung have set out, I think, starts to try and get to that. The importance of this is that complexity science, including ABM, have had this really rapid upward trajectory in its development, both in computational capacity and technology and so forth. Whereas decision-making has tended to remain relatively flat and geared essentially to single sector decision making. So what this modeling does two things. Firstly, it provides in a very explicit way and graphical with the spatial coordinates and so forth, the spatial representation. It introduces the idea of interdependence and cross-sectoral outcomes and trade-offs. The second point is it's really difficult for all of us because of this variation in rationality and our cognitive capacity to actually understand complex systems, particularly something like the Mekong Delta. So the way that these models actually, one of the major things they address is this cognitive limitation we have of understanding complexity. We can see it as a visual cue. We can see it as an illustrative map, which we tend to behaviorally respond to in a lot more favorable ways. So they're two really important outcomes for the modeling process. There's I guess some questions that come out of all this. I've made several notes, so it may take me a little while to go through these. I'll be as quick as I can. This idea of co-adaptation, really important. We mentioned the outputs that you've got from the model. Typically, what happens with decision making, it's always geared to the future. And typically the objectives meet some sort of criteria for what we might call a desirable future. And typically we have a set of decision makers, have a set of indicators of how they might monitor progress towards that desirable future. It's not exactly clear from the outputs that the indicators to monitor the future to see how the progress towards these desirable policy objectives or outcomes, it's not clear that the model is able to do that. I mean, Alexis or Chung can actually certainly address that. I raised that because we were involved with the MRC Council study, which was a fairly limited, I mean, it's a big program, but it was a fairly limited kind of process. However, one of the main things that I found from that is there was a forum in Siem Reap to present all the results. Typically, policymakers and high-level policymakers really didn't care about the hydrology. They really didn't care about all the climate modelling and so forth. What they were concerned with is what is the effect on the livelihoods and poverty reduction of their communities that they're responsible for. So that's why I mean, are the outputs the model produces, are these the kind of indicators of the future that decision makers really need to know? What I can see, the main output at the moment is a change in area, which is obviously very important, but that may not be the indicators that policymakers really need to look at. So a question would be, can your modelling framework be adapted to actually produce the kinds of indicators that are relevant to those decision makers? I think it can, but it's just not clear from the report. Oh, yes. In that slide 2.5, with this, the behavioural variables for the agents, individual agents to select a particular land use, I understand the equation, but it's not clear how the agents, the computational agents, how they actually select a particular land use. Is that based on a sort of an empirical basis from surveys or something, or is that a calculation within the model? Clarity on that would be useful for me. So, and the principal question I get out of all this is, we can see from all the graphics that a 90% adaptation is obviously the desirable outcome of all this. However, given the initial slides that Alexis produced and talked about, what we saw with this reluctance to adapt by farmers, both from Alex's work, Schmeigel and myself in 2015, whether it be reactive or anticipatory, we saw this reluctance to adapt. So the principal question is, how do you use the model to assist decision makers and farmers to get to this high level of adaptation? So it's how you actually apply the model. How do you challenge the beliefs or change that behavior for non-adaptation? I think you've done a fantastic job here, and it's really important work, but it's just now, how do you actually apply this and make it really useful for decision makers and for farmers and communities in the Delta? Thanks, Etienne. I think that sort of covers most of the points I have. Really good piece of work, really impressed.
Thank you very much, John Ward. So Alexis, Quang.
Maybe I can I can begin since I did part one, so I will let Quang prepare his arguments. So first of all, I would like to thank you very much, Chi and John, for accepting to discuss this chapter. And for us, it was quite important. You represent really two sides of I mean the big world of adaptation planning, and especially in the Mekong Delta or the Mekong region. And for us, receiving your comments and well, actually, it was really important for us that you could be there, and it is really important to hear what you said. And I will just move to the two main questions I can answer. Some of them I can't, unfortunately. First of all, regarding Chi's comment about the coupling of models, okay, and how far we have been to this coupling of models. It is still an open question. There have been real progresses in the last few years, mainly thanks to new computational approaches, possibilities to use artificial intelligence tools, for example, to combine the outcomes of models or to combine models. It's still quite complicated, well, technically complicated in some cases, okay, because obviously when you want to couple or combine models, you combine pieces of software usually, which have been designed with a very different perspectives sometimes, okay, and so there are a lot of work on the way in different communities to do that. It's not something new in modeling, actually, building integrated models. And I know, for example, that at CSIRO, they have been really impressive in integrating models regarding Australian climate change in Australia, for example, the perception of climate change in Australia. But building integrated models still remains something a little bit handmade, okay? So there are no industrial answer I can give you about come with your model and we will integrate it. And so for me, the other side of the answer is actually to say the integrated model is the outcome everyone is looking for. Okay, we want to have models that integrate, I don't know, hydraulic dynamics and social dynamics, or to answer very specific questions. But actually, building these models is also an opportunity for sometimes innovation. And the goal, I know that Quang and we are working, and me, who is here today also, we are working in the same perspective and with the same spirit. I mean, the idea of building integrated models is not only to obtain integrated models at the end that can be used by people. It's also a way to make people from different disciplines, different themes, different domains, and maybe different interests come together and discuss about what a model should be. Okay, to answer the question they have. So that's so we are progressing, and technically it is progressing, but conceptually and in terms of interdisciplinarity, it is not progressing as much as I would like, actually. But actually, the GIMS project and other projects, they are still here for a few months and weeks and years, etc. So I hope we will have some opportunities to maybe be a little bit better on this. Well, actually, I don't hope, I promise we will have very interesting results in the coming months in the GIMS project. And very quickly on John's remarks regarding the use actually of models. You are completely right. The thing completely right regarding the chapter and the presentation we made today. We in a way, we did not really care about how this kind of model would be used or could be used by others. Okay, so it's still a preliminary work depicting something, things that are possible and things that might serve as a basis for other systems. But in terms of, I know that in the community, for example, of ABM, there is a lot of work now trying to understand how to build dashboards, okay, that can be useful for policymakers or deciders at different levels out of models. So without people looking actually at the model or understanding maybe what the model is. Okay, so really having a kind of layer of abstraction based on the indicators they are interested in, and which would, based on these indicators, which would actually trigger the launch of specific experiments or simulations or whatever. So there is a lot of work on the way also on this, and I completely understand the interests, although I will probably never work on this myself. But for me, I think at some point, the models will really become useful when they will disappear. Okay. When we will not have to make a presentation about the models, but about the outcomes and how we use them. So that's the first thing. And the second thing is how to use these models to convince maybe people or to influence behaviors or different things. And the thing I did not really mention in my presentation, and Quang's neither, because it was not about this, but one of the main interests of agent-based modeling is the flexibility of this approach, because you can incorporate human agents in the simulations. Okay, and all the trends, all the works done right now in terms of participatory simulations, so letting people play some roles or maybe be a little bit more immersed in the simulations themselves, taking decisions, influencing the outcomes of the simulation by their own actions. All these things also participate to, I think, to the possibility to let people better understand what it means to explore a scenario, what it means to see the outcomes of their actions in a very complex system, etc., etc. Okay. So that's I will let Quang answer because I'm taking all the time and I don't want it. But this is what your remarks inspire me, actually.
Yeah, thank you, Professor Alexis Drogoul. I would like to add some in the question for question of G and also Professor Drogoul, because Three is for your question is how to use the scenario, and because we define the strategies ourselves, and we testing the strategy to demonstrate the model. But as Professor Alexis Drogoul explained, we can have a kind of participate modeling, and they can provide the idea, the solution from different stakeholders, and we can collect it, and it would be a good solution strategy. And in reality, we can, if we would define a solution, we have to discuss with a lot of stakeholders, and we collect their idea, and we test it in the model, and our model can with our model we can develop and select a best solution, but not the solution provided. It's just the case study, yeah. And I found in the chat there are some a question from Miss Pang Lu. She asked about the modeling technical. So I would say that in our model we use the multi-serial decision making is not too really rational decision, because the multi-serial is based on the weighted mean equation. The equation is something that is quite fixed, and some factor could be non-rational one. So, but in the model, in the agent-based model, we can for solving the rational and irrational decision in the model, in the agent-based modeling, we can define BDI architecture that I did in my thesis, and we can define a percentage of the farmer they can divide the rational decision, and the other they can imitate different behaviors for different type of farmer, and they can just imitate the people, and we can implement that kind of model. Yeah.
Yeah, I think this question about the rationality of the agents is important, interesting. Maybe you could develop about the kind of rationality that you use. I mean, in economics, we have a very narrow definition of rationality, meaning that the agent knows everything about everything pretty much. So in this sense, the agent makes rational decisions, but you can also have other types of rationalities where, and my understanding is that in your model, you basically are open to the agents can depending on the choice you make, can have these different types of rationalities, but maybe you want to explain a little bit further on this. And because we now move to also the larger audience questions. We have an interesting question by Quang.
John has maybe would like to make a comment.
Yeah, sorry.
Very quickly, Etienne.
Okay, so John.
Yeah, really good point about rationality. Look, it's just as rational for me to have other regarding behavior, for me to be a social rationality as much as an individual rationality. Agent-based models can certainly build on that. My main point is this. The agent-based models are not explanatory models. They're not hypothesis testing models. These are exploratory models. So they don't provide a definitive single solution. What they enable is for participants to discover their own solutions because of this, introduced this idea of interdependence and so forth, and emergent outcomes, which typically participants cannot foresee. That's the whole idea of emergence. That's really the principle is. So I think the main purpose of an ABM is essentially, it's a pedagogical tool. It prompts thinking, and particularly it acts as a prompt for systems thinking. And that's really what we need to have when we look at a complex problem like the Mekong Delta. So that it enables participants, decision makers, stakeholders, and so forth, really to discover their own sustainable solutions by acting as a pedagogical tool. That's really the power of an ABM. So thanks.
Thank you, John. Actually, I think that should be the role of any model, but I understand.
I agree.
This is
except if I was a physicist. If I was a physicist and I was doing hypothesis testing, I'm not a physicist. I think I'm a behavioral economist, but anyway, yeah, thanks.
So thank you. So maybe let's move to the few questions on the chat. So Quang, you started to answer one of those. I think there is one very nice question by Tuan as well. Tuan Vu, you may want to develop on that, Quang or Alexis. So vulnerability depends on many non-climate factors such as capacity, policy, infrastructure, and financial constraints. Have you considered these factors while evaluating changes in vulnerability? And similarly, the effectiveness of adaptation strategies depends on different factors. In addition, given the complex nature of socio-ecological systems, a good strategy for one group may have adverse impacts on others. So yeah, maybe you want to say how you incorporated or not this question so far in the chapter.
For me, very interesting question, and actually what is behind is a question of how do we capture and how do we use the diversity of strategies, especially when we begin to take into account local private adaptation strategies. Then we have to face a large diversity, which is, as Tuan says, is completely right. I mean, due to due to the very diverse nature of ecological systems, of social systems that may be involved, we have to face quite a diversity. So right now, in the model which has been presented by Wang in the chapter, we don't take this diversity into account. Okay, for many different reasons. One of them being that it would have been a little bit, well, we have to consider this model as a first step. And actually, it would have been a little bit complicated to expose all of its complexity in one single chapter. I hope we can expand this for a future report or paper or whatever, but our goal now is precisely to do what Toan is describing here, is to say, okay, we have a number of questions about the adaptation strategies in the Mekong Delta. So how can we rationally, I would say, take into account, implement these questions by diversifying the model, by taking into account different ecosystems, taking into account different water resources levels, underground water availability, for example. Taking into account also the different policies implemented by different provinces. Okay, and that's something to consider in the Mekong Delta, because you can have the same or almost the same ecosystems with the same or almost the same communities governed by two different provinces with maybe some different rules or regulations or even competing rules regarding the water resources or infrastructures, etc., etc. So it is something that we will consider. So it's a very good question. The only thing I can say methodologically is that agent-based modeling is precisely dedicated to this kind of approaches, where we hope that by putting a little bit of the complexity of the real world in the model, we can have some heuristics on how to make it evolve or how to answer some better answer some questions we might have about its dynamics. Quang, I let you finish.
Yes, of course, we in our model we can improve our model, and because the other factor would be model as the different input layer, and for the agent-based model we can take it into account. And for measure the effectiveness of adaptation strategy is really very interesting question. So I think we for measure the effectiveness of adaptation strategy is quite hard for us now, but we try to looking for an indicator to evaluate the strategy, the adaptation strategy. So even in the reality, it's very hard to define it.
Thank you, Quang. Thank you, Alexis, as well. So we understand that the next step will be to introduce different levels of heterogeneity in this general agent-based framework. So that's for the next few weeks and months. We had a last question on the chat, which is very interesting and is a good opportunity for me to introduce the last session we have on this webinar series, because it's really about the transboundary water governance. So that will happen next week, Wednesday, same time. And we will welcome Professor Anulak Kitikun, who was just appointed new CEO of the Mekong River Commission, and Dr. Lin Huing Fong, and they contributed to Chapter 8 of our special COP26 assessment report. And so they will really talk about this more regional dimension of environmental dynamics in the Mekong Delta, looking at the upstream countries. So Duan Van Binh, you may want to attend this webinar next week. So thank you again, Alexis, Quang, and John Ward and Van Pham Duan Chi for this wonderful discussion. Thank you also to the audience, and we welcome you again next week for this last moment on this Mekong emergency sequence. Thank you very much.
Thanks a lot.
Thanks, everyone. Thank you.
Thank you.
Thank you very much.
Thank you.